So this is 5.1, and this time we're looking at real-world problems and where we would use exponents. So if you take a look at this particular problem here, example 9 on page 317, it says calculate the growth in property value. So if a parcel of property increases in value about 11% each year for 20 years, then its value will double 3 times. So they want you to write an exponential expression that represents doubling 3 times. So take a look. We would write it as 2 to the third, because 2 to the third would be doubling 3 times. And if the property initially cost $25,000, how much would it be worth after it doubles 3 times? So again, it would be 2 to the third multiplied by $25,000. So then you do 2 to the third first, so that'll give you 8. And then 8 times 25,000 would make it $200,000. So it'd be worth $200,000 when it's been doubled like 3 times. So let's take a look at another problem kind of similar. Let's look at 85 on page 2, on 3, I think it's on 319, yeah. So page 319. Okay, and so we can look at some of these types of problems here. This one here is probably 85. It's a really nice one. It's showing you the volume of a box, and they want to know what expression would you write to create the volume of this box in here. So let's go ahead and take a look at how you would do that. So clear this. So we know that volume is length multiplied by width multiplied by height. And so the length of this one was 2x. And then the width of this was 4x. And then the height was just x. Alright? And so we multiply all the numbers. There's a 1 here. So that makes 8. And then I have 1x here, 1x here, and 1x here. So that gives me x to the third. And so this is volume. And so it would be, it doesn't have units here, so we wouldn't write anything here. But basically it would be units cubed, because we're talking about volume. And so that's basically all you have to do, is you're just multiplying just like you did all your other problems. Let's take a look at problem 88. So let's look at 88. So here's problem 88. It says compound interest. If P dollars are deposited in an account that pays a 9% annual interest, then the amount of money in the account after 4 years is this equation, P times 1 plus 0.09 to the fourth, and it says find the amount when P is $500. Alright, so let's write down all the important information. So I'll write my important information, important list. And so we know the equation is P times 1 plus 0.09, and that's to the fourth power. And they told us that the interest was 9%, and so that's what's right here, because we always take percent and change it into decimal. And so 9 divided by 100 is 0.09 as a decimal. So remember, percent is always divided by 100. Okay, and then the 4, this 4 right here is time. So time is usually, in this case I think it is usually in years. Yep, it's in years. So this is 4 years. And then we have an initial amount. The initial amount is the P. And so they said you have $500 to start with. Okay. So we go ahead and we're going to put it in. So it'll be A for our total, okay, what we'll have in the end. And so P is 500. And then we have 1 plus the percent in decimal to the 4, which is how many years. So the first thing I have to do is add what's inside parentheses. So that becomes 1.09 to the 4th. And then the next thing I have to do is exponent. So I'll do that. Let's see here. I'll go to clear screen. So I'll type in 1.09 to the 4th power and enter. So I'm just going to say it's about 1.4. Okay, so it's 500 times 1.4, and now I'm going to multiply by 500. So I'll multiply by 500, and I get $705.79. So $705.79 is my total. This is what I will have after 4 years if I was to do this kind of investment. That's kind of neat, because if you think about it, if I subtract out the 500 that I started with, okay, I get $205. So for me, putting money into an investment that after 4 years I get free $205.79. I didn't do any work for this. I just invested. I put it in, and I get this much money after 4 years and absolutely doing nothing. That's not too bad. I know I'm not going to get rich off of it, but at least I made some money. I didn't lose anything. So this is another example of where you would use real-world problems with exponents. And this one here is probably the most valuable. It really will help you see with car payments or house payment or investments for retirement. This is the equation that you use for that.